Okay, in the next section we're going to look at finding the domain of a function. So I went ahead and took a picture of how that's defined in our book. So you can kind of read through that, kind of the key things to look at, and the way we kind of have to approach it is that the domain of a function is going to be the set of all the numbers for which the value of f of x is a real number. So all of the x's we can put in that will work. And what we have to do is we have to look to exclude or leave out numbers from the domain that are going to cause division by 0 and any values that result in an even root of a negative number. So, for example, that's given here is a square root. I can't take the square root of a negative. So any value of x that's going to give me a negative underneath a square root has to be something that's excluded or left out of the domain. Okay? So we'll look at a couple of examples here. Find the domain of each function. So f of x is x squared minus 7x. So the thought process has to be, okay, are there any values of x that I cannot raise to the second power? Or are there any values of x that I cannot take and multiply by 7? And the answer is no. I can square any number and I can multiply any number by negative 7. So the domain of this function is simply going to be negative infinity to infinity. Okay? There aren't any numbers that have to be left out. So let's look at B. We've got a quotient. Whenever we've got a fraction, we have to be aware and remember that we are not able to divide by 0. Okay? We cannot divide by 0. So what we have to do is look for values that would cause that to happen. And to find those, we take the denominator and we set it equal to 0 to see what values of x are going to cause that to happen. So we have to solve the quadratic. So remember, to solve quadratics, you've got quadratic formula, you've got factoring, completing the square. So we're going to see if this factors because that's the fastest route. So x minus 3, x plus 1 equals 0, which means x is going to be 3 and negative 1. So if x were either of those two values, that denominator, that x squared minus 2x minus 3, would end up being equal to 0. And we cannot allow that to happen. So those are the values that have to be left out. So we say that the domain is the values of x's from negative infinity to negative 1, okay, union with negative 1 to 3, and union that with 3 to infinity. Now the union just means we're joining all those groups together. So by using that union with the negative 1 and the union between the 3's, it shows that the negative 1 and the positive 3 are being left out. Okay? So basically we're taking all of the values from negative infinity to infinity except the negative 1 and the positive 3. Okay? So anytime that you've got a fraction with variables in the denominator, you have to set it equal to 0. And any values you come up with, those are the values that get left out. Okay? So part C, we've got a square root. Well, what do we know about square roots? We know that we cannot take the square root of a negative. So the approach that we have to take is that whatever it is under that radical, in this case the 3x plus 12, that value has to be greater than or equal to 0, because I cannot take the square root of a negative. So now I simply solve. 3x is greater than or equal to negative 12, which means x has to be greater than or equal to negative 4. So I can take any x from negative 4 up, and it will work in here. So the domain of that function is going to be a bracket because it's got the or equals to, and it's going to go from negative 4 up to infinity. Okay, gotta clean that up here a little bit. Okay, so the domain is negative 4 to infinity. Okay, so let's look at D. Again, this time we've got a combination. Not only do we have a quotient, not only is there a fraction, but there's also a radical in the denominator. Okay, so normally we would say that with a radical we would say greater than or equal to 0 as we did in C. But here, we cannot let that denominator equal to 0. So instead of saying 14 minus 2x is greater than or equal to 0, I have to say that it strictly has to be greater than. because I cannot allow that 0 in the denominator of that fraction. So when we solve, I have 7 is greater than x, or I could rewrite that and say that x is less than 7. So what's my domain going to look like? X is less than 7 means I'm going from negative infinity all the way up to 7. And now, since there's no equality there, the 7 is not included, so I have to use a parenthesis. Okay? So, kind of looked at an example of something that's defined for all x's, a quotient where there's a restriction in the denominator, a radical which has a restriction, and then a quotient with a radical which has a similar restriction but just a little bit different. So, what I want you to do is determine the domain of each of these functions, and then I will check these problems at the beginning of class tomorrow. Okay? In addition to that, I want you to write a summary. Okay? Write a summary of what you learned in this lesson. Okay? So just a short write-up of what you learned in this lesson, put it in your own words, and do these 4 problems, and that will be due tomorrow in class. Okay? We'll see you then.